Hello friends, I'm Saurabh. Let's have a look at another interesting problem today, which is how to find maximum size square submatrix with all ones. So the problem statement is, given a matrix of dimensions m cross n having all entries as 1 or 0, find out the size of maximum size square submatrix with all ones. Let us take one example to understand this. Consider the following matrix. Some of the square submatrices with all ones are here. Maximum size square submatrix with all ones has size 3, so return 3. Please note here we have highlighted only some of the square submatrices with all ones and not all. Please note that we are searching for maximum size square submatrix with all ones and not maximum size subrectangular matrix with all ones. Now let's have a look at the algorithm for solving this problem. We will use dynamic programming strategy to solve this. So first step is to create an empty table of same size as of input matrix, which is m cross n. Now let us understand what each entry of this new table will signify. So value of table ij is size of maximum square submatrix with all ones with matrix ij as bottom right element. Let us visualize this through a diagram. Consider the following matrix. Let us take I equal to 3 and j as 2. So maximum square submatrix with all ones with matrix 3 2 as bottom right element has size 2. So table 3 2 will have value 2. I hope this is clear. So the first step was to create an empty table having same size as of input matrix. Now let's move on to next step, where we would populate values in the newly created empty table. Now set values in table based on the following conditions. If I equal to 0 or j equal to 0, table ij will have same value as matrix ij. Let's understand how. When I equal to 0 or j equal to 0, that is in the first row or first column, if matrix ij equal to 0, then table ij will be 0. Why? Because there cannot be any submatrix with all ones with this cell as bottom right cell. If matrix ij equal to 1, then table ij will be 1, because then the element itself is the largest square submatrix with all ones, so size is 1. Else if matrix ij is 0, then table ij will be 0. Why? Because if current cell itself is 0, then there cannot be a square submatrix having all ones that includes this cell. Else set value of table ij as minimum of matrix I minus 1 j, matrix I minus 1 j minus 1 and matrix I j minus 1 plus 1. We will explain this condition in detail in subsequent slide. During step 2, maintain largest element added in the table and finally return it. Now let's understand why do we set table ij as minimum of matrix I minus 1 j, matrix I minus 1 j minus 1 and matrix I j minus 1 plus 1. Consider the highlighted entry which we have to fill now. Look at the values on left, up and diagonally above entries. Now have a look at the entry in the green. What does it signify? This signifies that there is a square submatrix of size 2 having this cell as bottom right corner. Similarly, for the entry highlighted in yellow, there is a square submatrix of size 2 having this cell as bottom right corner. Finally, for the entry which is diagonally up, there is a square submatrix of size 3 having this cell as bottom right corner. Clearly we can see that the maximum square submatrix with current cell as bottom right element can be obtained by taking minimum of the three sizes of the three highlighted square submatrices plus 1. If we do not take the minimum size and take a higher value, then we will be including a 0 and hence we will not get a square submatrix with all ones. Let us visualize the algorithm through an example. We will set values in first row and first column same as values in first row and first column of input matrix. We have already discussed the reason for the same in previous slides. Let us calculate values for remaining cells. Now the value for the current cell will be calculated from the minimum value of 3 cells as shown in the diagram plus 1. So we will get 1 here. Similarly for the next cell also we get 1. Similar is the case for next cell also. Now for the current cell, minimum values from the 3 cells comes out to be 1. So value of current cell is 2, which signifies that there is a submatrix with all ones having this cell as bottom right cell. This can be visualized from the highlighted region in the diagram. Let's move on to calculate value of next entry. Here matrix 2 1 is 0, so table 2 1 will also be 0, because there cannot be a square submatrix having all ones that includes this cell. In a similar manner, we will calculate values of all other subsequent entries. The largest element in the table is 3. We can visualize the square submatrix having all ones corresponding to this entry in the diagram as well. 3 is our solution here, so return 3. Time complexity of the algorithm is of order m into n, and space complexity is also order m into n. Have you checked our iDeserve web portal at www.ideserve.co.in? We are uploading new topics every day. Please check it out and leave us your feedback. Please let us know your valuable suggestion on current topic. If you liked our video, please subscribe to our iDeserve channel, like the video and share it with your friends. Thank you.